Have you ever seen something so magical, so otherworldly, that it felt like it was pulled straight from a science fiction movie? What if I told you that right here on Earth, there's a creature, or rather, billions of tiny creatures that have the power to turn ordinary water into shimmering, glowing light? This isn't a special effect from a Hollywood blockbuster. This is real, and it happens in our oceans every single night. Imagine dipping your hand into the sea and watching it come alive with an ethereal blue glow. Every ripple, every splash, igniting a galaxy of stars right at your fingertips. This incredible natural spectacle is called bioluminescence, and it's one of the most mesmerizing and surprisingly common phenomena in the marine world. It's a living light show, created by countless microscopic organisms that have mastered the art of making their own light. So, how do they do it? And why? Let's dive deep into the glowing waters and uncover the secrets of the ocean's living lanterns. The star of this aquatic light show is a tiny, single-celled organism called a dinoflagellate. Think of them as microscopic plankton drifting through the ocean currents. By themselves, they're completely invisible to the naked eye. But when they gather in massive numbers, forming what's known as an algal bloom, they have the collective power to set the entire ocean ablaze with light. These blooms can be so vast that they stretch for miles, creating surreal glowing tides that wash ashore. It's a breathtaking sight, a neon blue wave crashing against a dark beach. But the real magic happens when these dinoflagellates are disturbed. Any kind of movement, the gentle lapping of waves, the wake of a boat cutting through the water, or even a person swimming, triggers their incredible light-up response. The water doesn't just glow, it explodes with light, tracing every motion with a brilliant, fleeting trail. It's like nature's very own motion capture system, painting the dark water with strokes of liquid light. So why do these tiny creatures put on such a spectacular display? It's not for our entertainment. This brilliant flash of light is actually a clever and dramatic defense mechanism. Scientists call it the burglar alarm effect. When a small predator, like a tiny crustacean, tries to eat a dinoflagellate, the plankton flashes brightly. This sudden burst of light does two things. First, it can startle and scare off the immediate attacker. But more importantly, it acts like a beacon in the dark, attracting the attention of even bigger predators, like fish, that might be lurking nearby. The bigger predator sees the light, swims over to investigate, and ends up eating the smaller predator that was trying to eat the dinoflagellate. It's a brilliant, high-stakes game of distraction and survival. By sacrificing itself to create a flash, the dinoflagellate population as a whole is protected. It is an incredible example of how even the smallest life forms have evolved complex strategies to survive in the vast, competitive ocean. The color of this light is almost always a stunning blue-green, and there's a very specific reason for that. In the vast darkness of the ocean, not all colors are created equal. Wavelengths of light, like red and orange, are quickly absorbed by water and don't travel very far. Blue-green light, however, has a shorter wavelength, allowing it to penetrate deeper and be seen from a greater distance underwater. This makes it the most effective color for communication and signaling in the marine environment. Whether it's to startle a predator, attract a mate, or lure in prey, blue-green is the universal language of light in the deep. It's a perfect example of evolution at work, tailoring a biological function to the specific physics of its environment. This is why when you see videos of glowing beaches or sparkling kayak trails, the light always has that signature mesmerizing aqua hue. It's the color that life has chosen to conquer the ocean's darkness. These glowing events aren't confined to one remote corner of the world. Bioluminescent bays and beaches can be found in various locations, from the famous Bio Bay in Puerto Rico to the shores of the Maldives, California, and Australia. In some places, the glow is a constant, year-round attraction. In others, it's a seasonal phenomenon, appearing for a few weeks or months when conditions are just right for the dinoflagellates to bloom. Walking on one of these beaches at night is an unforgettable experience. With every step you take on the wet sand, you leave behind a trail of sparkling blue-green footprints, as if you're walking on stars. It's a powerful reminder of the hidden life all around us. The sand itself isn't glowing, but the water trapped between the grains is teeming with these light-producing organisms, each one flashing in response to the pressure of your foot. It transforms a simple walk on the beach into a magical interactive art installation, painted by nature itself. So what's the science behind this incredible glow? It all comes down to a simple but elegant chemical reaction. Inside each of these organisms is a molecule called luciferin. The name itself comes from the Latin word lucifer, which means light bringer. When luciferin combines with oxygen, it undergoes a chemical change, and this reaction is catalyzed or sped up by an enzyme called luciferase. The result of this reaction is the release of energy in the form of a photon, a particle of cold light. It's called cold light because, unlike a light bulb or a fire, this process generates very little heat. It's an incredibly efficient way to produce light, converting nearly all the chemical energy directly into visible light. This fundamental process, luciferin plus oxygen equals a glow, is the engine behind almost all bioluminescence in nature, from the tiniest plankton to the most complex deep-sea creatures. And dinoflagellates are far from the only creatures that have mastered this trick. Bioluminescence is surprisingly widespread in the ocean, especially in the deep sea where sunlight can't penetrate. It's estimated that up to 90% of deep-sea life uses bioluminescence in some way. Jellyfish pulse with rhythmic light. Certain types of squid can emit clouds of glowing ink to confuse predators, like a luminous smokescreen. The infamous anglerfish, a resident of the ocean's midnight zone, uses a glowing lure dangling in front of its mouth to attract unsuspecting prey in the pitch-black darkness. For these animals, light isn't just a defense mechanism. It's a multi-purpose tool. They use it to hunt, to hide by camouflaging themselves against the faint light filtering from above, and to communicate with each other to find mates in the vast, dark expanse. It's a silent, secret language written in light. It's important to distinguish bioluminescence from another light-related phenomenon, fluorescence. While they might look similar, they are fundamentally different. Fluorescence requires an external light source. A fluorescent object, like a highlighter or certain corals, absorbs light of one wavelength off an invisible ultraviolet light and then re-emits it at a different visible wavelength. If you turn off the external light source, the glowing stops. Bioluminescence, on the other hand, is self-generated. The organism creates its own light through that chemical reaction we talked about. It doesn't need to absorb light from the sun or any other source. It's a self-contained lantern, capable of turning itself on and off at will, deep in the darkest parts of the ocean where no external light has ever reached. This ability to create light from within is what makes bioluminescence so unique and so vital for life in the deep. The sheer scale of this phenomenon is mind-boggling. The wakes of ships and even massive submarines navigating through blooms of dinoflagellates can leave behind vast, glowing trails that are visible for miles, sometimes even from space. These glowing tracks, known as Milky Seas, have been documented by sailors for centuries and were once a maritime mystery. We now know they are caused by billions upon billions of bioluminescent bacteria. Even the largest animals on the planet, blue whales, can trigger spectacular light storms as they swim through dense patches of krill or plankton. Imagine a creature the size of a Boeing 737 gliding through the water, its entire body outlined in a brilliant, swirling aura of light. It's a sight that few have ever witnessed, a powerful collision of biological giants and microscopic light makers, painting a fleeting masterpiece in the dark canvas of the ocean. Bioluminescence remains one of the ocean's most magical and captivating secrets. While we understand the basic chemistry, there's still so much we don't know. How did this ability evolve so many different times in so many unrelated species? How do these organisms control the intensity and duration of their flashes with such precision? Scientists are still working to unravel these mysteries, studying these glowing creatures to learn more about genetics, biochemistry, and the intricate web of life in our oceans. Every new discovery reveals another layer of complexity and beauty, showing us just how inventive and adaptable life can be. It's a humbling reminder that even in the 21st century, our planet's oceans are still a frontier of exploration, holding secrets that are waiting to be illuminated. In the end, the ocean glows for a simple, profound reason. Because life, in its endless ingenuity, evolved to light up the darkness. From a single plankton's defensive flash to a whale's majestic glowing passage, this living light tells a story of survival, communication, and the incredible beauty hidden beneath the waves. It's not magic, it's biology, but it feels like magic all the same. Thanks for watching. What other deep sea secrets do you think we should expose next? Let me know in the comments below, and don't forget to subscribe for more journeys into the amazing world around us.